Good morning, friends. In the previous video, we were able to demonstrate the fault sharing in Java. And in this video, we will do the follow-up where we will modifying the same program to resolve fault sharing and improve performance. So in the previous run, we already noted it down here that once we are demonstrating the fault sharing using the unpadded long variable. So the number of threads, as you can see that the performance is getting worse and worse as the number of threads increase because it was because of the fault sharing. So let's solve this problem now. So in the fault sharing, our demo class, so this was one we used for fault sharing demonstration. And I created another class, another inner static class, volatile long padded. As you can see here in this value, we have got another one, two, three, six other long variables here and another 6 here. So total 12 long variables are also there, which are in the same object. So what it means is that how we are going to solve this fault sharing is that because if you go back to this diagram, if the object, if there are like more than like 8 objects or 16 long objects in the long variable, in the same cache line, so it will be already occupying the whole cache line. So there is no scope that there are another variables from another threads which are going to be manipulated in the same cache line. So this is why I have this padded longs here, and we'll just manipulate this part. But whenever this object is created, it will be already occupying the whole cache line, whether it's like 64 bytes or in the modern 128 bytes or even more, because this 6 plus 6, this 12 long variables would be 12 multiplied by 8 is like much more than the cache line. So we are guaranteed that whenever this is created, there would be only one object, one variable for this value occupying 8 bytes for this volatile long padded. There would be no other variable by another object by in the same cache line. So this is what we mean by padded. Okay, so let's demonstrate this in the test case. So it's similar to long and padded. I have got padded longs here. I've just created a static import. So you can see this static import here. And everything is same as before. I just created another array of padded longs of containing 4 objects. And now in this test case, we will demonstrate fixing fault sharing by padding. My test case is also ready. Just to save some time, what I will do is that I will copy most of the stuff from here. So let me copy this and then paste it. And now let's make some small changes where we will be creating this padded variable. Okay. So let me change this because we want padded enable. I'll create this method soon. And here for the join, I will just add it, the interrupted exception here. And here also I will change from unpadded to padded. Okay, now let's create this unpadded. So I'll alt enter, create method here. It will do the same thing, int, and let's mark it as k. And here also I will just copy the one which I have created here. So let me move this method here. So Control Shift down. I just use Control Shift down. It will move inside here. And let me copy this as well. I will just change a small part, which is to use padded longs. So just copy this again. Maybe you can further refactor this. We just create one enable method here and then pass the appropriate array because it's almost same here. I'm just changing it to padded longs. I think there is one scope of improvement that instead of having 2 methods here, we can just pass the variable this array as a parameter here, as an argument here. Okay, so let's keep it as it is for now because we want to demonstrate this fixing. Okay, so everything is done. We have got this created padded enable. So let me just revise a bit. Let's revise what we have done so far. So this is very much similar to our previous demonstration of fault sharing. Let's go back to this class again. Here, this volatile long and padded is only having like one value here, but it can be like if there are multiple objects having this only one variable container for value, it's very much possible that both multiple objects are sharing the same cache line. And that's why the fault sharing is very much possible. So how we improve it is that we just padded this object with multiple, like 12 extra long variables, each of like having 8 bytes. So 8 multiplied by 12 is 861 in 96 bytes are already occupied, and the further this 8 bytes for this, only this would be used. This is our main business for our business code here. Only we are using this value. Other 12 are just used for padding it. What it means is that whenever this object is created for volatile long padded, if the cache line is only 64 bytes, normally 64 bytes or 128 bytes, it's very much guaranteed that there would be only one object residing inside this cache line. That's why fault sharing is not possible, because it needs to be having multiple objects in the same cache line, which are manipulated by different threads. So this is what we did. We padded it so that only like one object is there in one cache line at a time. So then we actually have our method exactly same as before. What we did, I just copied it, and here we are creating padded longs array, which is containing 4, which is same as before, and unpadded longs. We have created like 4 objects for this, and exactly same as before. We are creating starting from first thread to 4 threads, 1 to 4, and for each of the one thread will be always guaranteed that it will not be having any fault sharing, as we have observed in our previous unpadded version. So every time, the first time, it would be fast, as we can see. But as number of threads increases, it means that the possibility of having fault sharing is more, and that's why it will create in. But in this case, because we have already padded it, the fault sharing should not happen, and that's why we will demonstrate it by running this test case. So let's run this test case now. We expect that it should be not having any fault sharing. Okay. Okay, you can see that this time it is like just running, not increasing as much. Here we see that it starts from 1.5, then 3.2, and then 3.4. As the number of threads increases, it even increases to 5.165. But here it's quite consistent. It is just taking this number of. So let's run it multiple times again and see that whether the performance, and compare the performance with padded versus unpadded. Let me run it again. So it's running now, and let's see the performance now. Yeah, you can see that it even went down. So with number of 1 threads, first time it took 1865, then second time it took 2088, and then in the third it even went down. So it never exceeded much more, as we have seen here. It keeps on increasing with the number of threads. But in this case, we can see that because of padded, it even decreased from the number of threads from 2088 to 1894. If you run it multiple times, we can see the difference. I just ran the whole test class, and you can see that this is the padded version. It starts with 1146, 1338, 1718. So the fault sharing is gone here. But if you see the same unpadded version, it would be started with 985, because there's only one thread. There is no possibility of fault sharing, but the performance gets worse and the number of threads increase from 2565, 457 to 60, almost 6 seconds. So let me run this again for the whole test one last time. So it's running, and so first it is running for padded version. Okay, you can see there's always 111 so far, and it is already completed for, now it is running for with the fault sharing unpadded one. As you can see that it starts with 1172, then it's, oh my god, it's getting even like double. Okay, because I think a lot of fault sharing is happening now. Okay, so we can see the results again. Padded version is not exceeding more than like 2735. For the first 3 times, it was even like less than 2 seconds. But for unpadded version, because of fault sharing, it even reached to almost 6 seconds, 5.8 seconds. So guys, this was all about fault sharing problem, or problem number 7. In the next video or the next chapter, we will implement read-write log. This is also a very common problem which has been asked, to implement your own custom version of read-write log, because this is only you are going to understand that what is the reading writing semantics which is implemented inside the Java API for the re-entrant logs. So see you all in the next chapter or the next video.